Eval. I'm co-founding CTO of Campanja. I like climbing, paragliding, and bicycling. And prior to Erlang, my favorite programming language was Perl. And the reason I liked Perl, I think, was that it was a very, very short route to get started. You only had to write a few lines of code and use some cpan modules, and you had some basic, duct tape application that did at least something. But now I'm going to talk about switching to Erlang for fun and profit. So, what is Campanja? Campanja is a company doing search engine optimization software, and we're solving problems for big advertisers who buy a lot of clicks on the internet. We have a minimal customer-facing dashboard, so we don't do much interaction and UI stuff. Most of the action is in the back end. Today, we mainly use Erlang, and we're about 20 full-time employees, and we have moved into a new office, and we are expanding and also hiring. But that was not how it started. So it started like I think most SEM companies start, such as marketing companies, that is. And that is as a productivity tool, because it's a very manual business, because in Sweden it mainly revolves around Google as a search engine and buying clicks in Google. And since Google wants to automate as much as possible, what's left is all the kind of manual tasks. And that's how things started out. My friend Ivan was working at an internet marketing agency building advertising campaigns, so selecting different keywords that were relevant for certain sites and then writing ads to go along with these keywords. So when you search for contact lenses online, there will be an ad that says something like, buy cheap contact lenses, shipping within 24 hours, click here, or something like that. And that was very boring, so he started writing his own program to kind of help him automate this. And when I joined, this was in maybe October, November 2007, and I joined sometime around the end of November 2007. We were focusing on a very, very short time to market, and we wanted really, really cheap hosting because we had no revenue whatsoever. So that was kind of our main considerations, not having to do work, cheap hosting, and short time to market. So the period between 2007 and 2010, we focused on the SEM productivity. We tried to solve media agencies' needs of not having to work very much with each customer, just bringing in new customers, making them a little bit happy, and then buying more clicks forever. Because that's kind of how my picture of the traditional media agency world is, that you build a basic advertising that works, and then you just leave it to run itself, and you take on the next customer. And that's why you want to have lots of productivity in that area. So Ivan had started building a software client on the .NET platform, so it ran on Windows, where you could very efficiently copy and paste keywords and ads and build campaign structures. So there was lots of kind of repetitive tasks that were eliminated if you used it. And there was some need for a backend, so that I started building on the LAMP stack together with some Perl. So MySQL running on Linux and Apache and PHP. And throughout this period we were about 2 to 3 full-time employees. But then, and I think even at this point we started encountering two problems actually. One of the problems was data. And the thing is that, a big advertiser can have, first we had, okay, so an advertiser has 5,000 keywords. And then we got another advertiser that had 10,000 keywords, and each keyword generates statistics. So throughout the year, you get 365 statistical data points per keyword. And then you get an advertiser with 100,000 keywords, and this all starts exploding in into very big tables. So we had fairly large data sets. The queries that we wanted to run against the database were hard to pre-compute because you get new statistics every day, and in some cases you want to think about seasonality, which is, you don't buy winter jackets in the summer, so we can't take the statistics for the winter jacket season where we try to calculate the value of a keyword in the summer. So that makes them also hard to pre-compute. And since there's new data every day, there's not much use in caching the queries as well. and we found that MySQL was fairly hard to scale for our use cases. And the other problem that kind of comes from this is concurrency, because I think, for one, advertising is kind of inherently parallel, because there's lots of people clicking around on the internet all the time, and they do it at the same time. And also, with the slow queries from the databases, it's a very good approach to do asynchronous I/O to kind of try to handle that. So that was the other major problem that we kind of had. And that led us to the story about how we switched to Erlang. So the first major change that happened actually was that Google introduced something called preferred pricing. So before, they had an API, and we made requests to the API all the time to get more statistics, or add keywords, or remove keywords, or manipulate advertising in different ways. But the preferred pricing and the API, each API call cost a little bit of money. So there was a big penalty for doing many API calls and this major program in a certain way. But then in June 2010 actually, Google introduced preferred pricing, which basically means that if you handle enough money, you will get the API calls for free. So this really changed the rules of the game. So we could start focusing on doing more rather than less. And then 1 month later, we actually signed our, at that point, biggest customer to date, which is a site called avito.ru. So it's a Russian site that's sort of like Blocket or Craigslist. It's a classified site where you can list used items for sale, and you can buy used stuff from other private persons. And that, they were a very big advertiser and still are, so that introduced a very immediate need to scale our resources and databases and stuff like that. And what happened after we kind of coped with that whole challenge, is the next month here, or maybe you don't see it, but yeah, it was a big challenge basically, optimizing all the SQL queries, making sure that we were able to handle all the clicks and stuff like that. And then the queries that we used to run for the old smaller customers became much slower for this much bigger customer. So we needed to really start to address our two big major problems. And our first attempt at kind of attacking the asynchronous I/O part was actually Node.js. And let me tell you a little bit about our hopes when we kind of selected Node.js as a prototyping platform for our new asynchronously driven product. So we realized that since it's JavaScript, it's probably fairly easy to get started. You just copy it from internet and paste it, and it will maybe work. And at the time, we also had the idea that we wanted to really kind of maybe. We weren't really sure what we were doing, so we figured, maybe we want to be able to tweak it as we go along, and that introduced the need to kind of run more or less untrusted code that was more or less custom, or we thought we had it neededly. So that was another plus, that it's very easy to run JavaScript without exposing yourself to a whole area of security holes that would arise in other languages if you just eval some random code. So. And then, internet said it was fast, so we were like, yes, we hope for that. And we hope that it will bring short time to market. And I guess it's fairly easy to be charmed by trendy stuff on Hacker News and stuff like that. So maybe that played in as well. So we started coding away, and what happened was actually rather a disappointment. Performance was not really what I had hoped for, and when you do multiple kind of asynchronous calls for the same request, this was kind of a REST-based service, then you get callback hell, or at least you did back then, or the way we did it resulted in callback hell. So it was just a callback, and then another function that gets the data from the first one, many nested levels of callbacks, and that was a bit frustrating to work in that kind of a setting. It worked, but it was not nice. And then the error handling wasn't very good either. And I'm actually going to show you an example here. So this is kind of a basic HTTP server that you can run using Node.js. So we import some modules, there's a simple debug function, we create a server, we start responding to the request, we collect some post data. So we assume that the client is doing a push request, we're not checking this anywhere or something like that. And then we're kind of trying to read all the data, and then we return the JSON output hello world. And then here is some error handling code. So here we're trying to kind of catch errors that may occur during this request. And we define which port to listen to, and we start the server, and this is like starting the server, and here we start getting a request. And then in the other kind of box, I'm doing a curl request, and I'm sending just 3 characters as payload, but I forged the content length header, so it says that I'm sending more data, but I am not doing it. And then curl is starting to wait for more data from the server, but nothing is happening, so I'm pressing Ctrl+C. And then curl terminates the connection. And what happens here is that I first get the kind of waiting for data debug, and then got data debug, and then it's waiting to get more data, but then the error triggers because the client has disconnected. And then we kind of print client error colon and the error says parse error. Error colon parse error. So that wasn't very helpful. I mean, it didn't tell us that the client terminated the connection or anything like that. So yeah, that was, you know, there's lots of scenarios where things can go wrong, and it's the error messages aren't always very helpful in Node.js. So that was also a big disappointment. So how could we solve this? So we think, you know, maybe Scala can help us replace Node.js. That was kind of the next thing that we started to look at. And I guess there are several good reasons to at least consider the JVM. And what we hoped for was that, you know, we would get better error handling than we got from JavaScript, and perhaps better support for multiple cores, because Node.js, at least when we tried it, you had to run one instance per core, and then you had to do load balancing in front of that, and that was ugly as well. And hopefully we would get better performance from the JVM, and it would be more mature, because Node.js wasn't very mature at the time that we tried it. It was new and trendy, and yeah, I don't know. And also there's lots of libraries to use in the kind of whole JVM ecosystem, so that was, I guess, a good reason in my mind to use it. And it wasn't Java, so that was also a big plus. We started doing some prototyping, and performance seemed to be much better than with Node.js. I mean, one problem that we actually run into was that, you know, some examples in Java is rather hard to translate into Scala. In my opinion, it's such a complicated language. And I mean, I read the book, and then there's, you know, yeah, it's not, you know, straightforward to kind of just try to understand how to use it, and you need lots and lots of classes to get things going, and you still need to kind of fit it into the framework of Java, and I didn't really like that, so I was, you know, more happy than with Node, but not really happy. But then, you know, a random occurrence happened. So in my spare time, I trained something called Campanja, which is self-defense discipline that's invented in Israel, or at least fine-tuned by the Israeli military, and it's a very good way to focus on something other than work. And there was one day when I had been training in Campanja, and somebody had kind of elbowed me on the inside of my elbow, so I had lots of pain and I couldn't sleep. So I was laying awake at night, and it was 4 o'clock, and I was like, okay, so I'm not going to sleep tonight, what am I going to do? And I figured that I might as well do something useful with my time, so I started surfing around on the internet, and I found, because I had a friend who had been talking a lot about Erlang, and he was really impressed by what he had seen, so I figured, you know, why not? The syntax, it's really weird, but maybe I'll give it a shot now that I'm just, you know, sitting here in lots of pain. So I downloaded a paper called Making Reliable Distributed Systems in the Presence of Software Errors, and started reading it. And by morning, when I went to work, I was convinced that, shit, I should give this a try. It seems really interesting, actually. And this was sometime in February, And here is the first commit message on our first product with Erlang. So it's actually on a Sunday in the evening, but this is what it looked like. And the first impressions that I got of Erlang was that, you know, hot code loading is very, very useful for fast iteration. I was really impressed by that. And modules are so much more simple than classes, so that was also a great joy. It was so much easier, or more simple at least, to understand how Erlang was working than to try to realize how to fit something into a big kind of Java ecosystem. And we did use Gen event actually, but it was mostly pure Erlang. And I don't know if that's because I didn't read enough. I just got excited at once and kind of dove into it, but. Or if that's kind of how most people start using Erlang, who don't kind of go any kind of formal education when it comes to the language. So,
do you actually mean Gen server?
No, Gen event, not Gen server. Yep. Yeah, you have to go back and remember just commit them, and you can look at it. So. Yeah, and then. Kind of in March, we did a second prototype using Erlang, so this was another product, and it's a very informative commit message. This was actually on a Wednesday, so it was more normal working hours, but after we kind of tried to build that product, and it worked well that time too, we started realizing that Erlang really seems to fit the kind of problems that we have with concurrencies. So after the 2 successful pilots, we started to have Erlang as the preferred language for all our new projects, or almost at least, at Campanja. And then in April, we kind of got started with a dirty init commit on the third product, which is another of our major projects at Campanja. And here we can see we didn't do releases or stuff like that, of course. We just started it using shell scripts. So here we're starting the enets somewhere in the supervision tree, in the wrong way perhaps, I don't know, but that's how we really got started. But during the first year there was some surprises actually, that from given what I had read about Erlang and my first impressions, I was really kind of surprised about. And I guess the first one is actually HTTP client. That is in the main OTP distribution. Because what happened when we started making more concurrent requests was that we realized that there was a bug switching the responses. And this is like, is this even possible? So that was a really kind of scary realization that maybe not everybody is using HTTP as heavily as we do, or all the people who have done it have already switched to HTTPC or some other kind of eyebrows or other library to do that, because that was, I didn't believe my eyes first when I kind of started to realize this. Another kind of issue that we ran into was with eMySQL, and it was, we later discovered that some other people had run into this as well. And this is when you have multiple connection pools to different databases perhaps, and you start running lots of queries, so you start putting queries in the wait queue as well, because there are no connections free in the query pool. Then what happens before they did the patch for issue number 20, which is resolved now, so that was kind of the conclusion, you should follow GitHub very closely. But what happened was that eMySQL was starting to send the wrong query on the wrong connection. So all of a sudden we would get like, this table does not exist in this database, and we're like, what? How am I coding? Am I tripping now? What's happening? But really it was eMySQL who was messing things up. So that was also really a surprise, and I didn't kind of expect that from Erlang. And another library, also from GitHub. Everything is from GitHub here, so it's random code on the internet. It was a memcache client that was only using one connection, and that made it kind of cap out at 400 lookups per second. And we were like, oh shit, how can we, isn't memcache faster? What the fuck is this? The concurrency in Erlang is infinite, and But then we kind of realized, okay, so we need something with the connection pool, so we switched to Erlang, which solved that bottleneck. And I think a third kind of example of the immaturity of some of the libraries out on the internet, and I think this is kind of perhaps a general problem for people trying to apply Erlang in non-standard use cases, outside of telecom and with more weird, perhaps, or less common databases and stuff like that. I think the issue is that you kind of lots of people doing that are also learning Erlang at the same time, and that has some funny effects. So here in EZK, which is a Zookeeper client library for Erlang, we found this bug that when Zookeeper is terminating the connection to the client, then we wanted to get notified, but before they're trying to send the message to from, they have added, first they're kind of using gen server from, so it wouldn't work anyway, I guess, if they had just taken the PID and the tag and tried to do the bang. But now they're also putting a blocking kind of tag in front of that. So this code, I guess, have never been exercised during testing since the rewrite. And that, I think, is also one problem that, lots of the kind of peripheral technologies in the Erlang world are a little bit more immature than I expected. I was really, I guess, naive when this is a MySQL library, it has 19 issues and it probably works perfectly, and started just fitting it in and hacking away, but that is something to think about. And I think, as we grow as a community, these things will become much better, and the more people doing more and more crazy stuff with Erlang, the better. So these kind of things will hopefully go away. But that was some of our experiences, and kind of when we had the whole data problem or concurrency problem addressed, because in general I think Erlang has helped solving very much of our concurrency issues. We wanted to start to look at how we could get rid of MySQL as well, or to as large extent as possible. And the first thing that we started looking at was Riak, actually. And it was version 0.14.0. And this was actually before we started using Erlang, so we were kind of evaluating it in Scala. So this is what happened when we did kind of a simple test, because we have so much data, so we wanted to insert 100 million entities in Riak and see kind of what happened. And before we managed to do that, we actually ran out of memory on the testing server. But one thing that's interesting here is that kind of the write rate, which is seen, in the beginning of the parentheses, is like 4,000 to 300 requests per second. So that's very good. But then we don't get replies, and this might be because I'm bad at writing Scala or I haven't really understood that model, but it seemed like we just got reply for about 10% of our requests, and that was really kind of surprising. So after some 50 million requests sent to Riak, it crashed, because probably Scala is waiting for this other 90% of the requests that we don't get any reply from Riak about. But after this, we still tried to kind of figure out, what happened, and is Riak a good fit for us? And we started trying to kind of get all the keys back out and see how far we had gotten in the writes. And what happened was that we got like 159 megabytes in 30 minutes, and then I kind of lost my patience and just terminated it. And as you can see up in the far right corner, it's still kind of allocated 90 gigabytes on disk. So apparently some data had been stored in there, but it was very, very hard to kind of get it out again. And here it's kind of running top while trying to get the keys, and we're running 108% CPU and using most of the memory and most of the swap as well. So that was kind of a big disappointment, really, because we believed in Riak and wanted to use it, but I guess it wasn't fitting our use case very well. And this is something that I actually discovered afterwards when I was kind of preparing this talk. I wanted to go back and I didn't really do things correctly, and then I found this kind of interesting error message I don't know if you can see it, but here it says Riak core util c hash key. And so I guess it's the consistent hashing function that Riak uses to put the keys somewhere in the ring. And what we get back is bad match none, so maybe we're using the wrong keys. I don't know. The next kind of candidate as a NoSQL database to replace MySQL was BigCouch, which is Cloudend's version of CouchDB, and it was also Erlang based, so we thought that this is going to be awesome, but it didn't really measure up to what we wanted to do as well. And I guess it wasn't really fitting our use case either, and we still had this idea about server-side JavaScript that maybe shouldn't be considered in our case. So what happened next was that we switched to HBase and started trying that out instead. And HBase actually worked out fairly well for us, so I want to kind of tell you a little bit about HBase as a technology. So HBase is a distributed database. It was developed by PowerSet to mimic Google's Big Table database. And it's a top-level Apache open source project today. And on their website they promise random, real-time, read and write access to your big data atop clusters of commodity hardware with billions of rows times millions of columns. And I guess what they mean by this is actually the millions of columns thing should have a little bit of a star by it, I think, because most of HBase seems to be designed not to have a million columns on the same row, but a million different columns across these billion rows, rather. And they kind of, when you design your schema and put your data in HBase, you should really try to do tables that are tall and narrow, not short and wide. So lots of rows and few columns, and not few rows and many columns. But it's still a very, very powerful tool. And this is kind of a picture of their architecture. There is a master that controls different region servers, and all this is written in Java, so that's most why we were kind of trying to avoid it in the first place, but it actually works, so now we're pretty happy. And the region servers take a couple of regions each, and these regions are parts of the table that consists of a range of rows, so that's why you need to have so the partitioning is only done on row level. That's why you can't have millions of columns on the same row, because then you won't be able to spread that across different regions. And then they store it in Hadoop and the Hadoop distributed file system. And what HBase enables us to do is reads, writes, deletes, atomic increments, that is these counters, which is very useful and doesn't exist in Riak yet. And also scan, so you can read the rows in order. So then the big question was, how can we use HBase and Erlang together? Because we wanted to handle kind of the concurrency problems and then the big data problems and make them wow. So the first attempt was actually trying to access HBase using Thrift. But the conclusion that we came to was that, at least at that point, was that it wasn't really fast enough, because you're talking to the Thrift server, and the Thrift server is actually a Java client, and the Thrift server has only a limited set of workers, I guess, and I think you configure them to a fairly low number, really, it depends, but and then that is in turn talking to the different region servers. So the performance wasn't really what we hoped for. I mean, we did actually manage to put lots of data. I mean, today we store, I think, in the low hundreds of millions of rows in our HBase. So it did actually work to put lots of data there, and we managed, even using Thrift, to put in more and get it out again. But we wanted more performance. Then we kind of tried the J interface and the traditional Java client from HBase combination, so that the J interface can emulate an Erlang node, and we just send messages, and the Java client does the lookups. And that worked much better, actually. But there was still kind of a problem that you needed one or more JVMs attached to Erlang, and also the Java client isn't thread safe, so we had to do a lot of threading ourselves or have lots of JVMs, and that wasn't kind of the best fit for our use case. So then we continued looking, and we found another kind of interface or a client written by StumbleUpon, which is called async HBase. And they have a more asynchronous access pattern for HBase. So that actually, with that we could increase the performance of our access to HBase, and it did fit the model of Erlang much better. So that's what we're using today. But there's still some Java fear in there actually. So this is kind of a snippet of code from async HBase, and when you find log messages that says what the fuck shouldn't happen, lost 2 races and found the empty list of something RPCs, then you're like, okay, this might be scary code actually. So actually we had this one incident where we were kind of looking at some statistics in our system, and there was a counter that was 0, and we were like, okay, so what is happening here? Because this usually it's about in the low hundreds of thousands, and now it's 0 and it's increments 1 at a time, so we have lost a lot of increments. And then we started kind of tracing this down in the code, and what we found was that someplace in Erlang we start rolling up these counters, and then we apply the counters in Java multiple increments at a time, and the kind of rolled up counter was at 150,000. We're like, oh shit. So we haven't done it right in a long time, obviously. And then this was kind of a Friday afternoon, and we were drinking beer, and things were good, so we thought like, okay, maybe we should wait until Monday to resolve this issue. We should just let it keep incrementing in ets and see what happens. And then when we returned on Monday, the actual counter had been incremented in HBase. So maybe there's a very eventual consistency thing going on inside the Java black box that we have. So what I believe about the future is that we might actually want to implement a pure Erlang HBase client. And the async HBase repository is about 12,000 lines of Java code. So my question is, how many lines of Erlang will that be? And I think
120.
120, yeah, first bid. And I think we might get a much better kind of quality out of that as well. So summing up, I think that there's lots of kind of more or less mature software out there to solve problems other than telecom problems, and the more people who start using those kind of libraries, the better they will be, and I think there is lots of potential to solve really hard problems using Erlang, and I'm really happy that we did the switch to Erlang, and it has helped us really solve lots of hard problems, and also have a bit of fun and make some profit. And we have found a really good team, I think. To kind of there's lots of great Erlang talent out there, and that's also a really positive thing. So yeah, thank you.
Any question? I have a question.
Shoot.
So you can escape. We have 10 minutes of questions. So you said that you had problems getting MySQL. What problems exactly did you have?
So one of the problems is, when you start inserting lots of rows in the table, the kind of, I guess one of the problems was just, lots of the data that we store are arbitrary in nature. So we wanted kind of the schema-free tables, and we had done sharding on database level per customer. So we could just do the alter table per customer, but then again, you still, and when you have a big table and do an alter table statement, it takes a lot of time, but you can kind of work around that. You make a copy of the table, you do the alter table, then you switch the tables at some point. But it's also kind of a pain to maintain, I think, a high availability setup with MySQL, so you have to do replication. More or less manual or automated, but still you get 2 nodes, and then you can have other slaves, but you can't promote them to masters, or maybe you can, but there's lots of kind of sysadmin work involved in that we didn't really want to do. So I think that was kind of the main problem, really, get it distributed and highly available.
Great, because that's my second question. How do you do high availability with HBase?
So high availability with HBase, if we're going to go back to the kind of slide here. So there is actually one single point of failure. It's not in HBase, but it's in the Hadoop distributed file system down here. So the Hadoop distributed file system consists of two types of nodes. It's the name server, or the name node, and the data nodes that actually hold the data. And the name node is you know, in vanilla setup of Hadoop, it's a single point of failure. There are some kind of more or less experimental kind of applications that help us, that could help you make it highly available, like the avatar name node from Facebook. But that's really, I guess, the main kind of problem. But then the region servers, they kind of split all the regions in between them, and if one goes offline, the regions that name server holds will be redistributed by the HBase master. You can have multiple HBase masters working on the same cluster, and they synchronize through Zookeeper, where you can have multiple masters. So that's kind of working fairly well, I'd say. It's only kind of the name node that's a little bit scary.
Have you experimented with those alternative name nodes clusters? Have you tried them?
With the highly available name nodes? No, we haven't yet.
Is there any question?
I give you the back. Oh, it's okay.
So are you doing OTP now? Or is it still playing Erlang?
Yes, we have started switching to OTP, and I think maybe there might be, you know, some little part where it's not OTP yet, but the team has really done a great job, I think, switching over to OTP. And I also realized after some time that it was actually a very, very, very powerful thing about Erlang to do OTP, and that kind of made us switch direction. So I would say yes for OTP.
Have you managed to access HDFS from Erlang, or do you use any JVM code as a middleware?
We have not tried to access HDFS directly from Erlang, no. But I think our kind of first approach, if we were to do that, would be build another like very, very thin Java class and then integrate using interface, I think.
Any other question? So if there is no question, we'll conclude this talk. Thank you, Bernard.